as we started the reactions of carboxylic acid. So number one, is carboxylic acid. If we have a metal or acid plus metal, what it gives, it will give us salt plus hydrogen. So we will observe bubbles of hydrogen here when acid is reacting with metal. So carboxylic acid, if you take any example, like example CH3 COOH. So this is ethanoic acid. Eth because there are two carbon and they have a single bond, and oic acid because of carboxylic acid. It reacted with metal. Example, sodium is a metal here, Na. So what happened is sodium is more reactive. It will displace the hydrogen. So it will displace this last hydrogen of a carboxylic group. When it will displace this last hydrogen of a carboxylic group, it will form a salt, and this salt is called organic salt. As carboxylic acids are known as organic acids, and the salt which is formed is known as organic salt. So what will be the product? How you'll identify? Because you want to write a formula for a compound which contains CH3COO and Na. All these any kind of carboxylate ion is there, it will have a valency of -1 and sodium is +1. So when you cross multiply these valency, because it's 1, so the formula for sodium ethanoate will be CH3COO Na plus hydrogen. Hydrogen is a non-metal. Whenever non-metal element is there, it should always be diatomic except group 8. Is it clear? So this is how the product is formed. So first thing is completing a product. And what is the name of this salt? This is called sodium ethanoate. So ethanoic acid react with sodium metal. What it result? It will give sodium ethanoate plus hydrogen.
Sir, I forgot. O8 was for which thing
O8 is
again?
for
Ester?
ester. You can see here C double bonded with O and O. If you remember, I will just recall like the idea how you name. This is the structure. CH3, C double bonded with O, and Na is there. If you remember ester, naming of ester, the part which is attached with oxygen is considered as a branch. So this is a branch. But because this branch is a metal, that's why we don't write YL. So that's why we only write sodium. We don't write sodiamyl or sodial. We just write sodium because it's a metal. If it was a carbon chain, then methyl, ethyl, propyl, according to number of the carbon. And then because there are two carbon atoms, so we call that as H. They have a single bond between them, N. And due to this functional group, what we call that as O. O8. So it is sodium ethanoate. Now, how to balance this? If you take elements, individual element, because there are a lot of atoms, different atoms are there, so it will be difficult to balance. So what you will do, you will consider this as one part The shades, I'm using different shades to identify. You consider parts in a molecule so that you can balance it easily. So if I want to balance, how many hydrogens are there, like this part, because I'm considering separate, like CH3CO separate. You have 4 hydrogens on the left hand side, and how many hydrogen on the right hand side? 3 plus 2, 5. 2 here. So if I put 2 at this one, 2 at this one, and 2 with sodium. So when I put 2 with this whole part is balanced. This 2 is with hydrogen. This hydrogen is also balanced. And you have 1 sodium. Sorry, this one. This 2 is, the sodium is balanced. And with this hydrogen number is 2 on the left hand side, and hydrogen number is 2 on the right hand side. So it is balanced. So what I divide this molecule into small parts. CH3CO is one part, Na is another part, and small hydrogen is another part. So what I did, when I divide this into small parts, the shades are representing the parts. So now this pink shade, hydrogen in a pink shade are 2, and on the right hand side, hydrogen in a pink shade are 1 in the left hand side. So what I will do, I will put this 2. So hydrogen in a pink shade is balanced. Is it clear? Hydrogen in the pink shade is balanced because this 2 is with hydrogen. Now when I put 2, this gray shade CH3CO is 2 on the left hand side, and CH3CO is 1 on the right hand side. So I put 2. So this gray shade CH3CO is also balanced. But when I put 2, sodium is 2 on the right hand side. So I will put 2 as well. So sodium is also balanced. So instead of taking the whole elements like individual elements, I just divide the molecules into a identical molecule as one shade, so I can easily balance. If I balance that shade, it means I balance the equation as well.
Again, sir, the balancing only.
Look, we divide this molecule into different shades. How we divide this molecule into different shades? It's identical, like what it appear. You have CH3CO on the left hand side, you have CH3CO on the right hand side. So this is one shade. Is it clear?
Yes, yes.
And you have hydrogen on the left hand side, and you have hydrogen on the right hand side. That's another shade. And the third one, you have sodium and you have sodium. So means we have shades. If I balance the number of atoms in each shade, it means the whole is balanced, complete balance. So example, how many hydrogen in a pink shade? On the right hand side, how many hydrogen?
1.
On the right hand side?
On the right hand side is 2.
2. On the left hand side, how many hydrogen in the pink shade?
1.
So I put 2 so that hydrogen is balanced.
Okay.
Then this gray shade CH3CO, how many are there on the left hand side in the gray shade CH3CO? There are 2. So if I put 2 here, means that CH3CO gray shade is balanced. And then I have to balance sodium. This 2 is with sodium as well. So I will put 2. So sodium is also balanced. So this equation is balanced in terms of all the elements. You can count, you will find that this equation is balance. Because organic compounds or carboxylic acid, there are a lot of atoms. So if you try to balance in terms of atom, it will take a lot of time. So it's better you make a group of atoms and you give them a certain shade or a color or underline and just balance that shade. The whole equation will be balanced. I'll give another example. This is acid is reacting with metal. So CH3 COO H plus Mg. So what will be the product? Because magnesium is more reactive, so magnesium will displace this hydrogen. CH3COO. But now what is the product? Like how to complete a product? As I mentioned, this CH3CO is having a charge of -1 and magnesium is +2. Group 2 means +2. So how I will balance when the valencies are not same? We cross multiply. So what it will become? It will become CH3COO in a bracket 2 and Mg. And normally in carboxylic acid and their salts, the name of the symbol for the metal is last at the end because hydrogen is replaced. The end hydrogen is replaced. That's why metal is placed at the end. Plus, what is the product? Hydrogen will be the product. So this was ethanoic acid. This is magnesium. In terms of name, the name of metal is first. So it will be magnesium ethanoate plus hydrogen. Now to balance this equation, what we will do, we will just make this into ideal, like we have till CH3CO and CH3CO. You can see I give one shade to that. Then a hydrogen, that's the second shade. And then we have magnesium Mg. Now we want to balance. How many hydrogen on the left hand side, on the right hand side? How many hydrogens are in a pink shade, right hand side? In a pink shade, only in a pink shade on the right hand side. 2. So what I need to balance pink shade hydrogen. So to balance this pink shade hydrogen, what I will do, I will put 2.
Add 2.
So when I add 2, hydrogen in the pink shade is balanced. How many CH3CO on the left hand side? This 2 is with this as well. So how many CH3CO on the left hand side? 2. How many there on the right hand side? Also 2. So that is balanced. CH3CO, it's 2 is there on the right, 2 is there on the left, so it's balanced. How many magnesium in a green shade? 1 and magnesium 1. So magnesium is also balanced. So I just have to put 2 before, then this whole equation is balanced. Is this clear?
Clear, sir.
Another acid, if you have propanoic acid, which is CH3, CH2, COOH plus I add example calcium or calcium I add. So what will be the product? Calcium is group 2. So this CH3COO, CH3, CH2COO, that is minus, and calcium is group 2, so it will be plus. So what will be the product? It will be CH3, CH2, COO in a bracket 2, Ca plus hydrogen as a gas. Then we try to balance it. So we'll balance in the same manner like CH3CO. There's a hydrogen and calcium. No, systematic way, calcium should be at the last, and you, but this is a systematic way for writing a formula for organic salts and organic acids. So we just have to put 2 here. So hydrogen is balanced. And if it is propanoic acid plus calcium, what will be the product? It will be calcium propanoate plus hydrogen. Is it clear? So acid plus metal will give salt and hydrogen. Organic acid plus metal will also give salt and a hydrogen, but salt will be organic salt. And it is named after the acid which is used to prepare, which is reacting. If it's propanoic acid, it will be propanoate. If it is ethanoic acid, then it will be ethanoate. Is this clear? Then another reaction, the second reaction of acid, all the reaction of acids are same as the reaction of carboxylic acid. The second reaction, if we have acid plus metal oxide, what will be the product? Salt plus water will be the product. So acid plus metal oxide, the result is salt plus water. Same thing, organic acid plus metal oxide will also give salt and water. Example, if you have propanoic acid or ethanoic acid, I'm writing a word equation first, plus sodium oxide. So reacting, if ethanoic acid is reacting with metal oxide, it will give sodium ethanoate plus H2O or water. This is a word equation. But it's a symbolic equation. Ethanoic acid is CH3COOH. Sodium oxide, because sodium is group 1, oxygen group 6. So sodium oxide formula is Na2O. This will result, this again, the metal will always displace this hydrogen. So what this result? It result in a formation of CH3COO Na. Why? Because I told you acetate ions or ethanoate ions, they all have valency. Ethanoate ion, propanoate ion, butanoate ion, pentanoate ion, all these ions have valency -1, and sodium is group 1, so it is +1. Plus the second thing will be H2O. Is it clear, the formation of this product? And to balance the equation, again, it's better you divide into shades, so it's easy. CH3CO, CH3O, that's one shade. Then H and H, that's the second shade. Then Na and Na, and then at the last oxygen and oxygen. So you try to just balance the number of atoms in each shade. So if I started with hydrogen here, because oxygen is already balanced, so that's why I started with the hydrogen. To 2 hydrogen in a gray shade, 1 hydrogen in a gray shade. So if I put 2, hydrogen is balanced. CH3CO in a yellow shade 2 on the left hand side, on the right hand side 1. So I put 2, that is also balanced. In a green shade, 2 sodium on the right, 2 sodium on the left, and in a orange or a pink shade, we have, actually it's orange, so we have 1 oxygen on the right, 1 oxygen on the left. So this equation is balanced in terms of all the atoms in each shade. Is this clear? Balancing. So when acid plus metal oxide, this will result in a formation of salt and water. If you are having butanoic acid plus calcium or magnesium oxide, what will be the product? What will be the product if butanoic acid react with magnesium oxide? The name of the product, it will be salt and water, but what is the name of the salt? Magnesium butanoate. Plus water. And butanoic acid is CH3, CH2, CH2, COOH. Magnesium oxide is, it's a group 2 element. So magnesium oxide is MgO. When they react, magnesium is group 2, so this will be CH3, CH2, CH2, COO in a bracket, in a bracket 2 Mg plus H2O. So gray shade, identical atoms we took. Then pink shade, we took magnesium. Blue shade, I took hydrogen. And at the last, I can take yellow for oxygen. Then we have to balance So 2 hydrogen in the blue shade, 1 hydrogen in the blue shade. So I put 2 so that hydrogen will be balanced. And others are all balanced. You can check. Is it clear? These are the reactions of acid with metal oxide and metal. There are more reactions of carboxylic acid with carbonates also and with hydroxides, but there's a similarity. Tomorrow first we'll discuss those and complete reactions of carboxylic acid, and then I will discuss the test paper with you, chemistry test paper. So you can go through your test paper today, sort out the question, like some of the question maybe you understand from by using a marking scheme. So you don't have to ask doubt for that. The question in which you, if you're not able to understand even by using a marking scheme, tomorrow you can ask your doubts. So I'll end the session and share the recording with you.